Okay, so now if I will give you an polynomial equation here, PFS is equal to, so an s power n, an s power n minus 1 plus and so on, a not s power 0. So in general I am written here. So for that one you can see here s power 4, and I am taking an example here, plus s cube plus 2s square plus 3s plus 2. You can observe this one. Here s power 4 quotient will be 1, that is an. And s cube quotient how much it is 1, that is a power n minus 1, and s square quotient will be 2, that is a n minus 2, like that way. It's in generally I'm written the polynomial like this. For this one we cannot write the factorized form. Why? Because if goes on increasing s power 5, s power 6 and higher, and if you will go, it is very difficult to find out the factorized form of the polynomial here. So for that reason, so what we are doing, we are just dividing this particular polynomial into even polynomial of s and so odd polynomial of s. So that means the given polynomial we can divide into even polynomial of s and odd polynomial. Which one we can call it as even polynomial of s? Which s power quotient will power will be even, so that will be considered as an even polynomial of s. Means which are having the power will be as a even value, so then those terms we can call it as a even polynomials. That means s power 4 here plus 2s square plus 2. Why? Because 2 into s power 0. This we can consider as even polynomial of s. And if you will consider the s power of s, if it is odd, so those terms will be involved in the odd power of s. So now you will consider here we are we are converting the given polynomial into as e power of e of s plus o of s. Now, so the properties I will tell you. First of all, Hurwitz polynomial. Based on that, how can we determine whether the system is Hurwitz polynomial or not? What are those properties? First we can decide. So first of all the coefficients of the polynomial must be positive. So that is the first property. Means an minus 1. So a1, a0, like that way. So these quotients must be positive. Here all the quotients have positive sign. So means now first property will be satisfied. So first property is all coefficients must be positive. Second property is nothing but even polynomial of s and odd polynomial of s we are dividing here, right? So these two parts, the roots of these polynomials must be lying on the imaginary axis. Yes, definitely. So s power 4 s square, and if you will take that one, that roots will be definitely lying on the imaginary axis. Why? Because simple I will tell you here, s square plus 1. Suppose this is an even polynomial. If you will equate this one here, s square is equal to minus 1, that is s is equal to plus or minus j. So means it is existing on plus j and minus j, that is on imaginary axis. So the even polynomial of s or odd polynomial of s must be on the imaginary axis only, it has to be exist. Next, so the third property, very important, you have to remember this one. Why? Because this is the process we have to do it to determine whether the polynomial is Hurwitz or not. The third property is the ratio of even polynomial to odd polynomial. Here why I am taking even to odd, why not O to E? It's not like that. So we can take any one, but the condition is the numerator polynomial degree must be higher than the denominator polynomial degree. That is the case. That is only the thing. Suppose if it is an odd coefficient, it is an odd power of s, which is s power 5, then definitely we have to take odd to even. So now if I will take even power of s and odd power of s, that is s power 4 plus 2s square plus 2 divided by s cube plus 3s. That means the ratio of even to odd. And if you will perform the continued fraction expansion method, so all the coefficients of that continued fraction expansion will be having the positive value only. So that means I will do it right now. So for this particular function, you can observe this one. So that is I am taking s cube plus 3s, and this is s power 4 2s square plus 2. So now for eliminating this one, I am multiplying s, that is s power 1. I am multiplying s with this equation, s power 4 3s square. So then we can get minus this one is minus, means minus s square plus 2, and here it is s cube plus 3s. Now if I am multiplying with minus s, so then s cube, so and this is minus 2s, so then it is 5s, and again here minus s square plus 2, and again if I will multiply with the s by 5, so then minus s square, so then 2 will come here, so then it is 5s, then it is 5s again, so s by 5 s by 2, so then it will be 5s, so means completely it will be 0, then only up to that we can consider it is continued fraction expansion method. Now in this case, if you will observe this one, so in this case if you will observe this one, this coefficient, these are the coefficients, this coefficient all are must be positive, then only we can say that the given polynomial is Hurwitz polynomial. Here the coefficient s is 1, here the coefficient is s is equal to minus 1, here this is coefficient will be have the sign of positive, here 5s by 2 coefficient have the positive sign, here only one term will be getting negative. So because of that reason, the given polynomial, so the given polynomial it will be not the Hurwitz polynomial, that is the property. So and the very important point is, so this continued fraction expansion so must be carried out. So for this particular polynomial function, the polynomial must be have the highest degree and the lowest degree. Between these two, there must not be any missing term. If it is any missing term will be there, so then definitely, so that should not be a Hurwitz polynomial, unless and until if it is an even polynomial of s or odd polynomial of s. If it is given even polynomial of s, we cannot judge with that, so it is Hurwitz or not. Again, for that I will take a one example, and I will clarify how can we do for that one also Hurwitz polynomial or not. We can do it. Okay. Now we understand. Again, I will recall this particular Hurwitz polynomial strategy or Hurwitz polynomial properties. First property is if the polynomial is a Hurwitz polynomial, all the coefficients of s terms will be positive. That is the first property. Second property, we can so divide this as even polynomial of s and odd polynomial of s, right? So this even polynomial of s and odd polynomial of s, and these roots must be lying on the imaginary axis or at 0, no problem at all. Next, the third property is if you will done the continued fraction expansion for the ratio of even to odd polynomial, all the coefficients must be positive sign. So then we can say that Hurwitz polynomial or not. Suppose if I will give only even polynomial of s, if I am giving only odd polynomial of s, then how can we determine this Hurwitz polynomial? So now we can see that one.